Guys, I'm Jim and this is J&R Woodworking. I've been getting a lot of questions and comments and emails on dust collecting. How do you have yours hooked up? How should I hook mine up? What do I need? As far as the dust collector, it depends how big your shop is and how many things you're going to run at one time. I work alone, so I'm only running one machine at any single time. I may have two of them running at the same time. Like a lot of times I'll have the table saw running and I'll have a radial arm saw running. But when I get done cutting on the table saw to run over and use that, I'll close this gate and I'll open that gate. But as far as shutting the dust collector off while I go to the radial arm saw, you do not want to do that. I've watched several videos on YouTube where I seen one guy went to the trouble of installing micro switches on his gates. So when he pulled the gate open, it turned the dust collector on. Shuts the gate, shuts it off. He thought that was really cool. Worst thing you can do. Another one I watched, the man had a 3-horse machine. He had a friend of his come in that was an electrician, and he put in 3- and 4-way switch system on all his machines. Now, if you're not familiar with that, most houses all have somewhere in the house 2 3-way switches. That's so you can turn a light on here and shut it off over there. A 4-way switch system, you still need the 2 outside 3-way switches. And in between those, you can put as many 4-way switches as you want. You could put 100 of them in there. Well, that's what he did. He put the 4-way and 3-way switches on every machine. So when he went to the table saw, turned the blower on, used the table saw, shut it off, went over to the radial arm saw, turned it on. That is not what you want to do. When you turn a motor on, it will spike when it draws the amperage to get the motor started. Amperage kills. Voltage does not. You need amperage to kill you and to kill your motor. And that's what you're doing to it every time you turn that thing on. Mine is a 2-horse machine. I'm going to hook up my meter and actually show you what it spikes to when I turn it on. I made up these cords. This one is for 120 volt if you want to test anything. And what this will tell you, this one's for 240 volt. You can hook up an appliance, use your meter, you check the load that it's pulling, the amperage, you know what the voltage is, and there's a formula you can figure out. You add into that formula at the end the rate that you're paying per kilowatt hour on your electric bill, and it'll tell you that dust collector is costing me 20 cents an hour to run. Now, if that's correct or not, that's off the top of my head, I'm just guessing. But that's what this and a meter will do. This is an amp meter. You open this up and you clamp it around the wire. Now, you can't clamp it around the entire wire. You will get, I don't know what you'll get, probably a really goofy reading. You have to take the shielding off the wire. You make a short little cord, you separate these wires, and you put your clamp around one wire, and it will give you a reading. We're going to go over there and hook this up and try it out. Take my remote, and I'm going to wiggle you over there. And I hope you'll be able to see this. We're going to unplug the dust collector, which is 240 volts. We're going to plug this little test cable in. And we're going to plug this in. And we're going to clamp this meter around here. We set it on amperage. And clamp it around one of the wires. Now I'm hoping you can see this without a reflection from the lighting. Now this is going to react quick, so don't blink your eyes. Now right now it's running at about 6.5 amps, but when it started it spiked up to about 52 amps. That is what you want to get away from when you start up your motors. When I'm out here working during the day, I'll start that thing up in the morning. It will run all day long. I will never shut it off. Some days if the wife hollers, says lunch is ready and it's going to be a quick lunch, 10, 15, 20 minutes, I'll let it run. I won't shut it back off. Now the piping I use, a lot of guys ask me about the piping. I use all metal pipe. There's one piece coming down, or actually the main line over on this side of the shop is at the bottom. This pipe is coming up, it's going overhead, and it's coming over to this piece that comes down over my blade. And I can also slide this over, and I don't know if I can show you. It also goes to the router table. I gotta tip this. Here's the insert for the router. But mine doesn't get shut off and turned on. Plastic pipe, it's heavy, it's 10-foot long pieces. If you can do it by yourself, you're doing really good. I watched one guy and he said, wow, he says, I walked past my dust collector pipe and the hair on my arm stood right up from the static. Static is caused inside the pipe from the dust flying through it. I've seen guys wrap copper wire around the outside of the pipe. Does no good. Static's inside, not on the outside. That's where it's being created. That's where you want to ground it. Another guy that's really good woodworker, he's got all this plastic pipe in his building, and he's the one that's mentioned his hair standing up. So I watched an episode where he drilled holes through his plastic pipe about every 2 feet. He put a screw in there and he figured it out so the screw was flush on the inside of the pipe so it didn't snag any dust or chips going through. Then he hooked wires to it. That's probably a worse thing you could do, because now as that static is going through that pipe, if a static charge builds up enough, it's going to arc and hit that screw. Now you've got the potential for an explosion. Once that arc jumps, that's a spark, and it could start a fire. The best thing I can tell you is just stick to steel pipe. It's no more expensive than plastic pipe is. Most of the stuff I buy, I get my stuff at Menards. It's cheaper than the plastic pipe is, especially when you start buying elbows and T's and Y's. Now, I tried to move this before and I messed up my video. There's that pipe coming up with a gate on it. It goes around the floor. I'm just going to swing this camera around. It comes up here. It goes under this shelf all the way down to the radio arm saw. And over here I have a whole house vacuum system. And that has to exhaust the fine dust particles somewhere. When you have this hanging in your garage for a whole house vacuum, it exhausts out the wall of the garage. Well, I didn't want to cut a hole in my building, so I just have it exhausting into this main trunk. Then it comes over here, it goes up. And there's an elbow here, it shoots across, hooks into a T, and that continues down to the other half of the wood shop. This one goes across to ceiling, along with that one back there. This comes down for the radio arm saw. This one comes down for this bandsaw and this joiner under the table. That one comes down to the radio arm saw. That end down there goes down to the bandsaw or the pin router or the other joiner, depending where I put the hose. The hoses I use, I buy, is this thin, cheap looking black. It's thin because of the reason. It's self-grounding. The inside is very thin. Around this ribbing is actually a steel wire. And when you get up to the top, you strip back a little bit of this piping, you let that steel wire stick out, and I crimp electrical terminal on the end of that steel wire with an eye in it. And I screw that to the pipe. So now all this is grounded too. I never have a problem with hair standing up on my arm when I get close to it. It's all grounded system. I hope this has helped you, give you some ideas of what you can do. Another thing I wanted to mention, I've got to get my meter back out here. Put this in the right hole. All my joints on my ducking is all taped with this aluminum tape. I do not use duct tape. This is an actual piece of aluminum, and it conducts electricity, and it also grounds the pipe. Here's a small piece I cut off. This is the front. This is the back. It has a backing on it that you peel off to expose the adhesive that sticks to the pipe. Now if you put a meter on this, we're going to check continuity when you touch the two probes together. I'm going to put this probe on the face of the material. I'm going to put this probe on the back side where the adhesive is. It does conduct through the adhesive. So as you're taping all these joints, it's making contact even better than the actual joint sliding together. You can screw them together if you want to, but still you need to seal the joints or you're gonna lose vacuum. I seal every single joint. The elbows, when I get them adjusted where I want them and I get the whole system hooked up, I go back and tape all the joints. I tape every single joint on that elbow. 1, 2, 3, 4, 5. Would be 5 joints. 2 of them are where the 2 pipes slide on, and the elbow itself has 3 joints that you can turn and adjust. I believe it's 3. I don't really know. It's been so long since I did anything on here. This tape is pretty cheap. I did this entire system in this building. I used 1 roll and probably 10 feet off of this roll. And when I have to change something, all you have to do is take a razor blade and cut around that joint. Because I don't use screws, I can pull the joint apart, change what I want, slide it back together, retape it, and you're good to go. So I hope this has helped. If you have any more questions or comments, put them in that description box below or send me an email, I don't care, and I'll get back with you. Woodworking is enjoyable, but let's not have any explosions. So until next time, keep your tools sharp, your shop dusty, and we'll talk to you soon.